For most of human history, the night sky felt like a silent place. The stars sparkled, planets drifted, comets came and went, and for thousands of years we believed the universe simply existed without speaking. But now, in the 21st century, with our giant radio observatories, deep space antennas, and the cutting-edge algorithms that sift through mountains of data, we've realized something shocking. The universe isn't silent at all. It hums, pulses, flashes, and occasionally shouts. The cosmos sends out signals, some rhythmic, some chaotic, some impossibly powerful, and a few of them are so strange, so far beyond anything we can explain, that they force us to rethink everything we think we know about the universe. The story of mysterious cosmic signals begins, fittingly, with one of the most important one-time messages ever detected, the famous WOW signal. On August 15, 1977, Jerry Eman, a volunteer at the Big Ear Radio Observatory in Ohio, was reviewing printed computer logs from the previous night's observations. The observatory was scanning the sky for narrowband radio signals, a kind of radio emission nature almost never produces on its own. And there, in a long paper roll of alphanumeric noise, he saw something impossible. A signal, lasting exactly 72 seconds, with a strength that spiked more than 30 times above the background. Eman circled the cluster of numbers and letters, 6EQUJ5, and wrote beside it one word, WOW. That handwritten moment would become one of the most iconic mysteries in astronomy. What made the WOW signal so extraordinary wasn't just its power or its precision. It came from a direction in space with no known stars in the immediate vicinity. It was exactly the kind of narrowband radio emission that, according to decades of SETI research, an intelligent civilization might deliberately use for communication. The signal matched the hydrogen line frequency, 1420 magnetars, the universal reference frequency thought to be a kind of cosmic calling card for any advanced civilization wishing to announce its presence. Scientists looked for it again, and again, and again. Nothing. It never repeated. It simply appeared once, spoke for 72 seconds, and vanished forever. The WOW signal was the first moment in history when humanity genuinely wondered if the universe was trying to say something to us. Fast forward decades. Our technology became vastly more sensitive. We built arrays of radio telescopes spanning continents, and suddenly, something new emerged from the noise. Signals unlike anything we had ever seen. They came from the farthest reaches of the cosmos. They lasted no longer than a millisecond. But in that tiny fraction of time, they unleashed more energy than the sun emits in 3 days. Scientists called them fast radio bursts, or FRBs, and they instantly became one of the most baffling phenomena in astrophysics. FRBs are so powerful that detecting one is like standing on Earth and catching the flash of energy from a star exploding trillions of kilometers away, compressed into the blink of an eye. Some FRBs are one-off events, disappearing forever like cosmic lightning bolts. Others repeat, but not in any predictable pattern. Some burst once a month, some dozens of times per hour. Some go silent for years, then suddenly erupt again. And their origins are scattered randomly across the universe. They come from dwarf galaxies, from spiral galaxies, from star-forming regions, from barren cosmic outskirts. They do not follow any pattern we can decode. The first repeating FRB, discovered in 2012, shocked everyone. FRB 121112 resides in a tiny, metal-poor dwarf galaxy 3 billion light-years away. At first, scientists believed FRBs must come from cataclysmic events, collisions of neutron stars, exploding stars, collapsing black holes. But a repeating burst means the source survives. Whatever is generating these blasts of unimaginable energy keeps going, over and over, without destroying itself. There are very few objects in the universe capable of something like that. Magnetars, ultramagnetic neutron stars, quickly became the leading candidate. But even magnetars struggled to explain the most extreme FRBs, which exceed theoretical energy limits. In 2020, a breakthrough occurred. For the first time, an FRB-like signal was detected not from a distant galaxy, but from within our own Milky Way. It came from a known magnetar called SGR 1935 Plout 2154. This discovery seemed like the long-awaited confirmation. Magnetars really could produce FRBs, but the relief was short-lived. The Milky Way FRB was thousands of times weaker than the extragalactic ones we regularly observe. If magnetars produce FRBs, then the ones we detect from other galaxies must come from magnetars so extreme that they bend the limits of physics. No magnetar in the Milky Way behaves like that. And so the mystery deepened instead of being solved. Some researchers have proposed exotic explanations. One theory suggests FRBs might originate from cosmic string cusps, hypothetical defects in space-time leftover from the early universe. Another idea proposes that FRBs are the energy signatures of dead, collapsing alien megastructures, possibly artificial satellites or Dyson-like constructs falling into neutron stars. A few scientists, like the respected Avi Loeb, have even proposed that FRBs could be leakage from alien propulsion systems, massive light sails driven by beams of energy. If a distant civilization used powerful radio waves to accelerate starships, we might detect that spillover from across the cosmos. While such hypotheses might sound like science fiction, the simple truth is this: no natural explanation fully accounts for all FRB behaviors. Some are periodic. Some are chaotic. Some burst thousands of times. Some never repeat. Some originate from environments where no magnetars should be. Some have frequency structures so complex they resemble engineered signals rather than natural noise. And the universe isn't done surprising us. Another class of strange signals has been gaining attention: perytons. For years, these mysterious bursts mimicked FRBs so convincingly that astronomers thought they were cosmic in origin. But they behaved oddly. They always appeared during working hours, and they clustered around lunchtime. After nearly a decade of confusion, the culprit was finally found: microwaves. Literally, someone at an observatory had been opening microwave oven doors too early, and the machines were leaking radio bursts. It was a hilarious reminder of the complexity of radio astronomy. But it also underscored the danger of assuming that every unexplained signal has a mundane explanation. Because not all of them do. Consider the Lorimer burst, the very first FRB ever discovered. Detected in 2007, it was so powerful and so far away that even today, scientists can't explain how any known object could produce that much energy in a millisecond. Or consider FRB 1809116, a repeating FRB with a 16.35-day cycle, the first periodic FRB ever found. Natural astronomical objects rarely produce such perfect clockwork timing. This suggests something orbiting something else, a neutron star near a massive companion, a precessing beam, or something artificial. Even stranger is FRB 22200120UE. This repeating burst comes from inside a globular cluster, an ancient stellar environment made of old, dead, metal-poor stars. Those stars should not be forming magnetars. It should be impossible. And yet, it repeats constantly. Theories now suggest that FRB 2020-2120UE may come from a millisecond pulsar, but if so, it is unlike any pulsar we have ever observed. Then there are the signals that defy classification altogether. In 2019, astronomers detected a series of radio pulses that exhibited an inverted dispersion measure, as if the signal had traveled backward through matter. That is physically impossible under our current understanding. Another burst appeared to shift in frequency in a way that mathematically resembled a chirped communication signal, a kind of encoding used in radar and digital communication systems on Earth. Of course, scientists are extremely cautious. Extraordinary claims require extraordinary evidence. But the data keeps piling up, and every new signal reveals just how little we understand about the electromagnetic language of the universe. If all we had were FRBs, the mystery would already be overwhelming. but the universe continues to whisper in other ways. In 1967, a graduate student named Jocelyn Bell Burnell detected a perfectly rhythmic radio pulse, one blip every 1.3373 seconds. It was so precise that the team jokingly labeled it LGM-1, Little Green Men 1. It turned out to be the first pulsar ever discovered, a rotating neutron star emitting beams of radiation like a cosmic lighthouse. It was not aliens, but it was the discovery of an entirely new class of objects and the start of a revolution in astronomy. The lesson was clear. Nature can be stranger than any fictional alien civilization, and yet some signals still push us to the edge of what nature should be capable of. Consider rotating radio transients, RATs, bizarre objects that emit pulses of energy sporadically, sometimes only once every few hours. Or the unclassified narrowband bursts that appear in narrow frequency windows that natural objects almost never produce, yet they appear and no one knows why. Or the SETI detections of signals that look unnatural but vanish before they can be confirmed. In 2020, a narrowband radio emission was detected coming from Proxima Centauri, the closest star to the Sun, just 4.2 light-years away. It looked artificial. It was at 982 MHz, a frequency rarely produced by natural astrophysical processes. For months, the scientific community debated whether it was the first alien signal ever found. But after extensive analysis, the signal was eventually attributed to human radio interference. The verdict was disappointing, yet essential. The process proved that scientists are ready to be cautious, critical, and uncompromising. Still, even with all the false alarms removed, we are left with dozens, maybe hundreds of signals that defy explanation. And the deeper our instruments reach, the more the universe responds. There's something profoundly humbling about receiving a pulse of radio energy that traveled billions of years before reaching Earth. The burst might have left its source before our planet even formed, before life emerged, before the sun existed, when the universe itself was far younger. These signals are like time capsules, fragments of cosmic history traveling across the dark ocean of space-time. What makes this even more astonishing is the sheer scale. Every FRB we detect is only a tiny fraction of what's actually happening. Astronomers estimate that up to 10,000 FRBs occur across the universe every single day. That means every second, somewhere in the cosmos, something unleashes unimaginable power. And we have no idea what most of them are. Some scientists believe that FRBs could become tools for understanding the structure of the universe itself. Because radio waves disperse as they travel through intergalactic gas, each FRB carries a fingerprint of the matter it passed through. By studying FRBs, we could map the invisible cosmic web, locate missing baryons, measure dark energy, and even test the limits of general relativity. The universe may be sending us messages, but they might be messages about its own structure, not its inhabitants. Of course, the possibility of extraterrestrial intelligence lingers at the edges of the discussion. Not because we assume aliens exist, but because FRBs and unexplained bursts fall into a category of phenomena we do not fully understand. When something violates patterns, breaks energy limits, or mimics engineered signals, the scientific method demands curiosity, not dismissal. In the end, the truth may be a mix of explanations. Some FRBs might come from magnetars, some from binary systems, some from exotic physics, and maybe, just maybe, a few originate from something we haven't yet imagined. What's undeniable is this: the universe is talking, not in words or sentences, not with intent or emotion, but in bursts of energy that echo across billions of light years. These signals are reminders that the cosmos is dynamic, alive in its own way, full of phenomena that stretch the limits of our understanding. We used to think the universe was silent. Now we know it has been speaking all along. The real question is whether we are finally learning how to listen.